Hi, my name is Annika, and I'm a first-year student studying electrical engineering at the University of Colorado Boulder. Today, we're going to learn about circuits. Have you ever played a game that requires batteries? How many batteries did you need? Why do you think some toys or games need more batteries than others? Toys that need more batteries usually need more power. You get more power by more voltage. Voltage is the force that pushes electrons through a circuit to produce electricity, and so more voltage means you need more electricity. Which do you think provides more voltage? 3 AA batteries connected in series or a single AA battery? If you guess the 3 AA batteries, then you're correct. This is because the chemical energy in a battery gets converted to electrical energy in a circuit, and there's more chemical energy available in a circuit with 3 AA batteries in series than in a circuit with only a single AA battery. In a circuit, electrical energy can then be converted to thermal or light energy in forms of resistance or light bulbs. Electrical circuits and batteries can be in series or in parallel. During today's lesson, we will learn what in series and in parallel mean. How do electrical engineers know how many batteries are needed to operate an electronic game or toy? One way they can determine the necessary voltage and current is to create a map of the circuit. Electrical engineers can use a map, also called a circuit diagram, to determine how much power a device needs to operate. The power that the device needs can come from 2 different sources. For example, do you know why some devices use wall outlets instead of batteries? It's because batteries produce a different type of current than a wall outlet. The current that comes from a battery is called direct current, while the current that comes from a wall outlet is called alternating current. Direct current, or DC, refers to the movement of charge in a circuit in one direction only. Batteries, solar cells, and some generators provide direct current. In AC, or alternating current, electrons are moved back and forth in a circuit. Because of this, the electrons only move a small distance around a relatively fixed position in the circuit. Devices like TVs, computers, and game consoles have hardware or equipment inside the device that converts the alternating current to direct current for operation of the device. Circuits can become very complex very quickly, and to see how the circuit functions, engineers draw circuit diagrams. What are circuit diagrams? Circuit diagrams are graphical representations of circuits or electrical devices. Think of a circuit diagram as a map. It tells engineers how a circuit works and makes it so that anyone who reads it knows how to build the circuit. Each component of a circuit has a corresponding standard symbol to use when drawing the circuit. Wires, which have a very low resistance, are represented by straight or angular lines connecting electrical components. A resistor is a device used to regulate the amount of current in a circuit. There are many different resistors, with resistances ranging from a few ohms to millions of ohms. The resistor is symbolized by a zigzag line. There are various ways to represent a light bulb in a circuit. In this unit, the symbol used for a light bulb is the circle with an X. A cell, or electrochemical cell, is represented by 2 lines of different lengths, positioned perpendicular to the wire line, to show that there is a voltage between the positive and negative terminals. The shorter line is the negative terminal of the battery. A battery is composed of multiple cells. Notice the symbol for a battery appears to look like 2 cells in a row, or in series. The symbol for a switch shows that the electrical connection can be open and closed at the contact. Let's talk about how each of these electrical elements are connected and how they work with each other in a circuit. The parts of a circuit can be connected in 2 different ways. When they are connected such that there is a single conducting path between them, they are said to be connected in series. As we can see, the path of the current can be highlighted with the laser. In a series circuit, the current can only flow down one path. When elements are connected across common points such that there is more than one conducting path through the circuit, they are connected in parallel. In this parallel circuit, there are 3 paths that the current can take. The first path can be seen as follows. This is the second path, and here's the third. A typical electrical device is composed of many smaller series and parallel circuits. In general, only very simple circuits can be entirely in series. When looking at circuits, we can mathematically find the relationship between voltage, current, and resistance. This fundamental mathematical equation is called Ohm's law. To be more specific, Ohm's law defines resistance. We can write it as R is equal to V divided by I, where R is the resistance of a circuit element measured in ohms, V is the total voltage supplied to the circuit by a power source measured in volts, and I is the current through the circuit measured in amperes. The equation can be rearranged to be V is equal to I times R to predict a voltage drop across a circuit element with a known resistance and a known current pass-through. The voltage supplied to the circuit, V, and the total voltage drop throughout the circuit, V total, must be equal and opposite. This means V plus V total is equal to 0. The total voltage drop through the circuit is equal to I times R total equals to V total, where R total is the total resistance in the circuit. While we will only explore how to apply Ohm's law to a series circuit in this lesson, we can also apply it to a circuit in parallel. In a series circuit, the current is the same across the entire circuit, and thus the voltage drop across each light bulb is directly proportional to that bulb's resistance. We can mathematically see this when we rearrange Ohm's law to be V is equal to IR. If we were to add a light bulb or remove a battery, the current across a series circuit would decrease. By adding a light bulb, we add more resistance, and by removing a battery, we decrease voltage. Thus, from Ohm's law, it can be found that current also decreases. However, if a light bulb were removed or a battery were added, the current would increase. When batteries are linked in series, the total voltage is the sum of the voltages of each battery. So, if we make a circuit with 3 1.5 volt batteries in series as the voltage source, the total voltage is 4.5 volts. Engineers link several batteries of the same potential together in series when they design products that require batteries with higher voltages. Circuit diagrams are the language of electrical design and engineering. These diagrams are maps that anyone can read to see how to build the circuit. When engineers design or build any electrical circuit, they either create a new circuit diagram or use an existing one. Interpreting circuit diagrams is an essential skill for electrical and many other types of engineers. Once built, these electrical circuits are used to light our houses, power computers, run cars, and pretty much every modern device that uses electricity. Check out the lesson on the TeachEngineering website and then apply what you learned about circuits in our associated hands-on activities: bulbs and batteries in a row, light your way, design build a series circuit flashlight, and build a toy workshop.